Hi. So here in one video we are going to learn divisibility rules of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 13. As you know, I have already done videos individually for all these numbers, for all these divisibility rules. But in this one video, I am just summarizing all the divisibility rules. So this will be a video where you can find divisibility rules for all these numbers in one place. So first is divisibility rule of 2. So as all of you know, a number divisible by 2 is an even number. So the divisibility rule of 2 says the number should have 2, 4, 6, 8 or 0 at units place. Any number which has 2, 4, 6, 8 or 0 at units place will be an even number and it will be divisible by 2. So the number should be like 24, 28 or 52 or 50 or 96. All these numbers will be divisible by 2. So let's check divisibility of one number, any one number in random. So I'll take 96. 96 when gets divided by 2, 2 fours are 8. If we subtract, we get 9 minus 8, 1. 6, 16. 2 8s are 16. If a number is divisible by 2, we should get remainder as 0. So here we are getting remainder as 0 and the quotient over here is 48. Right? So this proves that 96 is completely divisible by 2. Right? And then now we have divisibility rules for 3 and 9. Divisibility rule of 3 and 9 is very similar. It says sum of all the digits should be divisible by 3 and 9. This means if you are checking the divisibility for 3, the sum of the digits of the number should be divisible by 3. And if you are checking for 9, the sum of the digits should be divisible by 9. And yes, all these divisibility rules can be used recursively. What do I mean by that? I'll tell you. So if I take a number like 1368, if I want to check its divisibility by 3, what I have to do? Yes, first thing is I have to add all the digits. So I have to do 1 plus 3 plus 6 plus 8. 1 plus 3 is 4 plus 6 is 10. 10 plus 8 is 18. Right? This 18 should be divisible by 3. And if this 18 is divisible by 3, this 18 will also follow the same rule, isn't it? That means if 18 is divisible by 3, then 1 plus 8 is equal to 9. This 9 will also be divisible by 3. Yes, 3 3s are 9, leaving remainder as 0 and quotient is 3. That means this 18 is divisible by 3 and since this 18 is the sum of the digits of 1368, so this implies that 1368 will also be divisible by 3, right? Yes. And same is the rule for 9. So let's check with whether this number is divisible by 9 or not. So again we have to do the same things. 1368 is the original number and if it is divisible by 9, sum of its digits, which is 18, should be divisible by 9, right? And if this 18 is divisible by 9, sum of its digits again should be divisible by 9 and sum of its digits gives us 9 and any number is divisible by the number itself. This proves that 1368 is divisible by 9 also, right? So if we use this rule recursively for 9, ultimately we will get the sum of the digits as 9, isn't it? We should get, right? Like in this case, if we use this rule twice, I am getting sum of the digits as 9. And if you remember the table of 9, all the numbers which are there in the table of 9, if you add their digits individually, they give you 9. Isn't it? 9 plus 0 is 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9 again. So you can modify this rule for 9 and say continue adding the digits of the number you are getting till you get 9. And if you get 9, in the end the number is divisible by 9. Right? So this was the divisibility rule of 9. And then we have divisibility rule of 4. So if I take a number like 2632, divisibility rule of 4 says the number formed by last two digits should be divisible by 4. So according to this rule, if this 32, which is the number formed by last two digits, is divisible by 4, this 2632 will also be divisible by 4. So let's check the divisibility of 32. 4 8s are 32, right? And this gives us remainder as 0. So 32 is divisible by 4. That means 2632 will also be divisible by 4. So let's check its divisibility. 2632. If I try to divide this by 4, 4 6 are 24. 2 is the remainder. Let me note this 3 down. 4 5s are 20. 3 is the remainder. And if I note this 2 down, again it boils down to dividing 32. And 4 8s are 32. And we get remainder 0 again. And then we have divisibility rule of 5. And the divisibility rule of 5 is very simple. It says that units place should be either 0 or 5. So if you have any number like 115 or 2125, 68,450, all these numbers will be divisible by 5, right? And the logic for this divisibility rule comes from the table of 5. What is the table of 5? 5 1s are 5, 5 2s are 10, 15, 20, 25, 30, 35, 40, 45, 50, right? If you see all these numbers carefully, in the units place, we have either 5 or 0. So this was the divisibility rule of 5, and I think it's very simple. So we need not to talk much about this. And then we have divisibility rule of 6. Divisibility rule of 6 says number should be divisible by both 2 and 3. 6 can be written as 3 multiplied by 2, right? And if a number has to be divisible by 6, it should be an even number because 6 is an even number. The number has to be even number is covered in divisibility by 2, right? And since 3 and 2 are the factors of 6, the number should also be divisible by 3. Then only it will be divisible by 6, right? This holds good for any composite number. So I don't think we need to elaborate on this topic. And next divisibility rule is of 7 and 13. Both of them are prime numbers, but surprisingly both of them share the same divisibility rule. The divisibility rule says difference between the numbers formed by last 3 digits and the rest of the digits should be divisible by 7 and 13 respectively. So if you are checking the divisibility by 7, that difference should be divisible by 7, and if you are checking the divisibility by 13, the difference should be divisible by 13, right? Very simple rule. So let me take one number for 7. So the number I am going to take is 18,424, right? So here if you see, this 424 is the number formed by last 3 digits, and this 18 is the number formed by rest of the digits. And what is the next step? Yes, we have to find the difference. So to find the difference, I'll subtract smaller number from the bigger number. So bigger number over here is 424 and smaller number is 18. And if I subtract, let's borrow 1 from here, this becomes 14. 14 minus 8 is 6. 1 minus 1 is 0. 4 minus 0 is 4. So if this 406 is divisible by 7, 18,424 will also be divisible by 7, right? So let's check its divisibility. So let's try and divide this 406 by 7. 5 are 35 minus 10 minus 5 gives us 5. 40 minus 35 is 5. And if I note down this 6, 7 8s are 56, giving remainder as 0. So this suggests that 18,424 will also be divisible by 7. So let's find it out. So 1, 8, 4, 2, 4. If I divide it by 7, 7 2s are 14, 4 is remainder, 4 is noted down, 7 6 are 42, subtract 2, this 2 is noted down, 7 3s are 21, I subtract, I'll get 1, I'll note this 4, and 7 2s are 14, right? And again we are getting remainder as 0, isn't it? So what does it prove? It proves that 18,424 is also divisible by 7. So this just proves our divisibility rule, right? And now let's check the divisibility rule of 13. Divisibility rule of 13 says the difference between the number formed by last three digits and the rest of the digits should be divisible by 13, right? I have written these two rules together because both of them sound same. So it will be easier for you to remember the rules. That's why I have written them together, right? So let me take one number. So the number I'm going to take is 34,216, right? So the number formed by last two digits is 216 and rest of the digits is 34. So first step is to find the difference. So 216 minus 34, 6 minus 4 gives us 2, 11 minus 3 gives us 8, and then we have 1, right? So if this 182 is divisible by 13, this 34,216 will also be divisible by 13. So let's first divide 182 by 13 and see what we get. So 13 ones are 13, 8 minus 3 gives 5, 1 minus 1 0. If I note this 2 down, the new number is 52. Add 13, 4s of 52. And remainder as 0. This suggests that this 182 is divisible by 13. And this 182 is the difference between the number formed by last three digits and the rest of the digits. This suggests that this number should also be divisible by 13. So let's divide this 34,216 by 13. 13 2s are 26. 14 minus 6 gives us 8. I note this 2 down, it becomes 82. 13 6 are 78. And if I subtract, I'll get 4. Then I have to note this 1 down. 13 3s are 39. If I subtract, I'll get 2. And then if I note this 6 down, it becomes 26 and 13 2s are 26. 26 minus 26 is 0. Again, we have got remainder as 0. That means 34,216 is divisible by 13, right? And now we have divisibility rule of 8. So this suggests that the number formed by last two digits should be divisible by 8. If the number formed by last two digits is divisible by 8, the number itself is supposed to be divisible by 8, right? So let's take one number. So the number I'm going to take is 1184, and the number formed by last three digits is 184, right? And if this 184 is divisible by 8, the whole number will be divisible by 8. So 8 2s are 16, 2, if I note this 4 down, it becomes 24, 8 3s are 24, giving remainder as 0, right? So this suggests that this number should be divisible by 8, right? So if I put 1 over here, it becomes the original number, right? And it should be divisible by 8. So 8 ones are 8. 11 minus 8 is 3. 8 becomes 38. 8 fours are 32. 8 minus 2 is 6. 3 minus 3 is 0. And if I note this 4 down, this becomes 64. And 8 8s are 64. 0. Again, we have got remainder as 0, right? So this means that this divisibility rule holds good. And now we will learn the divisibility rule of 10. And it's very simple. It says the units place should be 0. So any multiple of 10 will have units place as 0. So I don't think I need to explain you anything about this because I think it is the simplest divisibility rule, right? And then we have the divisibility rule of 11. So the divisibility rule of 11 says the difference between the sum of the digits at even places and the sum of the digits at odd places should be either 0 or divisible by 11. So if I take a number like 51,579 and let's check its divisibility. So if I start counting from the right hand side, this is an odd place and this is an odd place and this is an odd place. So these are the numbers at odd places and their sum will be 5 plus 5 plus 9, that is 19, right? And then these digits will be at even places, right? And they are 1 plus 7 is equal to 8. And how do we find the difference? Yes, to find the difference, we do bigger number minus the smaller number, that means 19 minus 8. Yes, it gives us 11, right? So since this difference is 11, the number 51,579 should be divisible by 11. So let's divide and see. So the number for which we have to check divisibility is 51,579 and we have to check its divisibility by 11, right? So 11 fours are 44. 11 minus 4 gives us 7. And then if I note this 5 down, 11 6 are 66, right? And 15 minus 6 gives us 9. And now I have to note this 7 down. And 11 8s are 88. 17 minus 8 gives us 9. And then we have to note this 9 down. And 11 9s are 99. And again we are getting remainder as 0. So this proves the divisibility of 51,579 by 11. Or this is the proof for the divisibility rule by 11, right? So this was a video in which I summarized all the divisibility rules. I think it will be very helpful to you. So bye bye.